Welcome to the overview of Rapax and the $127 billion 5G slicing gap. And this presentation is all about how ephemeral services demand is requiring a new design of telecom operations. So, Henry Calvert, head of GSMA at Mobile World Congress last year, said that there's $127 billion that could be left on the table by not embracing 5G slicing. And so, what has effectively happened is that the telcos of the world have funded a complete RAN refresh. All the network works. Slicing has proved that it works. The bottleneck that telecoms are running into is that the OSS is built on 2000s technology and just doesn't have the real-time nature to be able to support ephemeral services that 5G slicing excels at. So, as you can see here, at the very bottom, you've got legacy services like MPLS and SDWAN. This is the common network services that so many telcos are well aware of. But it's the new services that 5G excels at. It's the autonomous vehicle. It's the drone surveillance. It's the concert slice for a stadium. And these are a matter of seconds, if not minutes and hours of a duration. And OSS was never really designed before 5G to be able to handle these. So that's the mismatch here. You have a service catalog that is set up for permanent entities and permanent endpoints. You've got inventory that is designed to be done once and never touched again. You've got correlation that requires fixed network topology. You've got root cause analysis that takes hours, if not days, to figure out what's going on. And the visualization you have sits on top of these so that you won't be able to see what's really going on when it's actually going on. That's the difference between what ephemeral 5G slicing is requiring to what exists in the networks of telecom today. So, a lot of people are saying that the network product teams cannot commercially support 5G slicing. And that's just not correct. The problem is that operations can't commit to the SLAs, which causes the network product teams not to be able to support it. You've got edge services, which are the highest margin growth, and they're ending up in hyperscalers environments, not in telcos. And then operationally, most operation centers are already burning out on the complexity of their services because the OSS solutions are just not modern enough to handle the headnets that people are deploying today, let alone ephemeral services, which is, as we talked about, are the highest margin, highest growth areas. So to do ephemeral services, you need these four things in your OSS. You need to be able to support dynamic service modeling, on demand as the service changes. You need cross-domain correlation that's going to go across to your RAN, your edge applications, and into business data. You're going to need root cause analysis that is completed in mere seconds to be any kind of use for ephemeral services. And then lastly, you're going to need real-time geospatial technology so that you can understand where the users are consuming these ephemeral services as well. Now, this doesn't necessarily have to be a rip and replace. You can overlay this, and that's what a lot of customers are doing. And so you can see your OSS, your BSS, your network edge, and your knock-in product teams all need to come together to make ephemeral services powered by 5G slicing reality. Now, the proof is at this year's TMF DTW Ignite, and there's a catalyst around this, supported by these groups of partners, to show off how these things are possible and what the value of the industry is. I highly recommend you going by and visiting this booth or seeing the demo of it at the end of June 2026. So here's the scenario. You have 3 sites, 113 devices in a heterogeneous environment. You've got 75 cameras, you've got Cisco switches, you've got Fujitsu ORAN, and you've got Percepto drones. And each drone can connect to these 3 different radio interfaces, and they will re-anchor to different antennas as they go along, so that this topology graph can reshape itself every 60 seconds. Now, when a new service gets initiated, let's say it's a standard port surveillance, we're going to dispatch a drone every hour for 15 to 20 minutes to go do detection of movement or anything that is out of place compared to the last. And so these patrols will go through at random intervals to check everything. If an intrusion is detected, an intrusion execution can happen to send a higher quality loitering drone to be able to observe this as the security or the police are dispatched. This way you could see in real time in 4K. This is a typical type of ephemeral service because you don't know when it's going to start up, but when it does, you need to have high quality through its duration. And as soon as it's over, it's no longer a problem, and it will never happen again. And this is how Rapax processes these types of services. And the BSS layer will be able to send this information, and AI can use this to understand how important the service is and what it means in real time. This is the geospatial, so you could see where every one of these cameras are posted out in the port, monitoring things, and then all the different perceptor drones. As they move, you'll be able to see them in your geospatial tracking. When you have a problem, we do that automatic correlation, and you could see the performance statistics, whether it be signal strength, battery percentage, battery remaining, whether or not a detection event has occurred. All of this information can be tracked not only as key performance indicators, but key quality indicators, as well as business level metrics. All of this can be rolled up and alerted if something goes wrong. If the drone loses signal strength, if the drone, for some reason, is running out of battery, and it shouldn't happen. These exceptions can be created and routed out to a remote network operations center so that they can understand why these automated services aren't working. This is the 60-second cycle, I like to call it. During this period of time, you may have a service instantiated, a problem may occur that a root cause needs to be generated, and all that information needs to be calculated, pushed through so that it goes back, and that the service is billed properly. The drones are certainly the value here. They're what's producing the value. But having slice-aware operations is really what is built to the customer. Now, this kind of service is actually not that difficult to be added as an overlay. So adding that observability and collecting the data, most of the network is probably already being monitored. It's just a matter of combining it with all the other different data feeds to be able to have that single corpus of data. And when you have that data, you can leverage AI to provide that root cause analysis. And that root cause analysis can be applied to the service modeling that the BSS platform has initialized, and so that you can understand the impact of whatever problems that the observability is seeing, so that you can alert at a business level, not just a technical one. Then that information then can be relayed back to BSS to say, hey, maybe credits are due here, or this was a successful ephemeral service. A successful surveillance slice was created and executed on this port. And we're billing the customer to what they're actually trying to get value from, surveillance instead of just bits and bytes. So the question comes to you before you're ready to roll out your 5G services. Have you had these 3 questions to your OSS team? Can your catalog instantiate an SLA-backed service that lasts only 18 minutes? Can you do that successfully? Can your correlation engine scope a root cause to a mission context in less than 30 seconds accurately? Does your topology view update geographically in real time? If you're hearing, hey, we can work on that, then it's a no. You should call and look at rapix.app, the website, or you can send an email at sales@rapix.app. And let's jump into the demo. So here's a perfect example of a surveillance trip that was initiated, right? It shows how long it is. It shows when it started. It shows when it's supposed to be done. You can see any kind of status that's going on in the system today. Now you can then look at the device in place here. Let me refresh this graph, and you can see that the battery dropped all the way down to 0% before it had to return back and charge. You can see the signal strength that's being generated. Obviously, when it got further away, going over the water, you can see that. And then you could see where the drone is in real time. Not in a docking station, but over water, as it's surveilling the entire environment. So again, if you want to see this live, please reach out to cal.com/Sean-Ennis. And you can set up an appointment with me. I'll be able to walk you through not only this demo, but everything else that Rapix can do for you. Thanks for your time today.